Okay, thanks for tuning in. I got some questions about 1.1, and I just wanted to make this to make sure that there's no confusion about anything, and I just want us all to start off with like a really, really strong foundation. So, when we're talking about probability, it's really, really important to understand that we are exclusively, well, as only as far as probability is concerned. We are exclusively dealing in this interval. So everything needs to be, any probability is going to be between 0 and 1, and that's inclusive. So let's talk about what that means. So an event with a probability of 0 or 0%, that means that it's going to be impossible, right? And the justification for that is like, imagine I have a bag with we'll do 5 marbles, right? One of them is red, one of them is blue. I have 2 purples and a green, right? And what if I were to ask you, well, what's the probability? What's the probability I have a yellow marble? Well, there aren't any yellow marbles in this bag, right? So there are 0 yellow marbles out of the 5. And so that's where the 0% comes from, right? So that means it's impossible. It's impossible. You cannot get a yellow marble out of this bag, okay? Moving on. So an event with a probability of 100%, well, that means it's absolutely certain. Okay, so let's reimagine this scenario. What if I were to change the question? What if I were to say, well, what's the probability of getting a marble out of this bag? Any color marble. Any red, blue, purple, or green, right? What's the probability I just get a marble? Well, let's look at our bag. Well, there are 5 marbles out of the 5 that are in there, right? So that it has to be 1, which is also obviously 100%, right? So nothing too crazy. Oops, sorry about that. Nothing too crazy. Number 1, pretty simple, right? So let's look at some more examples of what we would call certainty, right? 100% certainty. So whenever you see 1, you're thinking, ooh, 100%, right? So it says check, circle all that apply. So for example, let's talk about landing on a blue or red space on a spinner. Now, you're going to hear a lot of references to spinners, especially in like somewhat elementary probability. Well, this spinner has a red space and it has a pretty blue space. Favorite color is blue. Well, what's the probability that you land on blue or red? Well, let's find out. There's actually something, it's a bit more of a complex question. You'll see in a following chapter, right? But, well, there's blue or red. That's 2 desired outcomes out of the 2 outcomes total, right? And so therefore that is 100% certain. Also, just intuitively, we kind of understand that, okay, we can only land on red or blue. So it must be the case. It is certain that we land on red or blue. This one, choosing a red marble, is not 100% certain, right? Because if you have red or green, right, let's go back to this example. Let's say if I get rid of all this. Let's say I get rid of all this. And I say, well, what if we have a couple red ones and then 3 green ones? Well, the probability of getting a red in this scenario would actually be only 2 out of 5, or 40%, right? Definitely not 100% in this scenario, right? We have 2 red. We have 2 red out of the 5 total. Okay? So super simple, no. Drawing a peanut from a bag with 4 types of nuts. Well, again, there's other nuts in there. And so, you know, you might get an almond or something, or a cashew, which is objectively the best nut. Drawing a, oops, extra S, I'll fix that. Drawing a red card from a stack of 20 red cards. Well, yeah, if there's only red cards, well then, obviously you're going to draw a red card, right? It's certain. Same thing, getting a heads or a tails when flipping a coin. Well, I mean, is there a third side to a coin, or is it only heads or tails, right? There is two desired outcomes, either one, right? Out of the two, that's 100% as well. Okay, nothing too crazy. Even this, I would argue. I'm always happy if students are showing work and kind of thinking on paper, but even that is a bit of a stretch. You know, it's sort of intuitive. We understand. Oh, okay, like you're flipping a coin, you can only get heads or tails, right? So let's keep moving. Which of these values cannot, right? Keyword cannot represent the probability of an event happening, right? Which of these cannot represent? Well, I'll just tell you the answer. The answer is 1.2, and the reasoning is that 1.2 is greater than 1. Right? So remember our spectrum, right? We're between 0 and between 1. This implies that it cannot be less than 0. That is to say, we cannot have negative probability. That doesn't make sense. And it also cannot be greater than 1. And I'll show you can't be greater than 1. Can't be more than 1. So suppose for a moment. In fact, here, let's go back to our marble example right here. In fact, let me color these. All right, let's make these pretty. We got a red marble, another red marble, and then we got three greens. Wow, how pretty. And suppose this is incorrect, right? This is totally incorrect. But what if I told you that the probability of getting a red marble is, what if I told you it was 10 out of 5, right? Which is obviously 2, which is obviously more than 1. Okay? What if I told you that the probability was 10 out of 5? You'd say, we only have 5 marbles, right? How can there be 10 red ones? How can there be 10 red marbles? Well, the answer is that there cannot be, right? If there were 10 red marbles, then this number would have to be bigger. Okay? So that's the idea that probability has to be between 0 and 1. That's what I love about math, is there's always a logical explanation. Please excuse my dog. He is scratching at the door. I do not know why. There he goes. Hi, doggy. So number 4 gave a lot of people a lot of problems. So let's talk it through. So if you're rolling a 6-sided number cube with numbers 1 through 6, this is what we would call the sample space. Why don't we write all these numbers down? These are all the possible outcomes. And remember, when we're talking about a number cube, we're talking about this thing, right? It has the different sides. So there's one with the 2 dots. We have a side with 3 dots, and so on, right? 4 dots, and so on, right? So 6 sides. Which of the following represents the probability of rolling an even number? An even number. Very important. I recommend you circle that, because what we're asking is the probability of rolling an even number. Okay, so why don't we go ahead and you guys can circle. I'll highlight because I like the pretty color. Well, I highlighted all my even numbers, of which there were 3. And then on bottom, of course, we're going to have our total of 6. Remember, it's desired over total. And then you're saying, okay, great. But then you're looking at the multiple choice options and you're thinking, I don't see 3 over 6. Well, you may have to reduce your answer, okay? So reducing this, I know that, think about it this way. Isn't 3 just 3 times 1? And isn't 6 just 3 times 2? And can't I just cancel out those 3's? And what I'm left with is my simplified fraction, right? That's kind of what we would call like a post hoc justification. I already knew the answer was 1/2, so it was easy for me to kind of figure these numbers out. I think typically a student wouldn't do it this way. But again, I just don't have all the time in the world to show you guys like, all the best ways to simplify fractions. Maybe one day we can do a review day or something. Okay. So our answer is in fact 1/2. There are 3 even numbers out of the 6, but even there's kind of aren't half the numbers even. So half of the numbers are even. You have a 1/2 chance of getting an even number. Okay. And then number 5, which pair does not describe the probabilities of what we would call 2 complementary events? Right, so just a little bit of background. So what do we mean by complementary? The idea of being complementary actually comes from geometry, where you have a 90-degree right angle. And so let's say if this is a 30-degree angle, the complement to that would obviously be 60. 30 plus 60 gives us that 90, right? Now, this isn't really all that relevant, the explanation as to why we use the word complementary. But the idea is that we add up to 1. So complementary events add up to 1. Or 100%, right? So obviously, if we do 84% plus 16%, well, 4 plus 6 is 10, carry the 1, 9, 10, that's 100%, right? But we're asking which one does not describe. So obviously, A is a pair of complementary events. Let's do B, 0.50 plus 0.25. 0 plus 5 is 5. 5 plus 2 is 7. Oh, well, that must be our answer. This is obviously not 1, right? Not 1 or 100%. So that must be our correct answer. Let's just double check. C is a little funny. It's kind of a ridiculous example. I mean, obviously 1 plus 0 just equals 1, right? And so that actually is complementary. I'm sorry. So that cannot be our answer. It is complementary, so it cannot be our correct answer. So yeah, B is our answer there. And just make sure, we do the notes. I obviously don't grade those. If you have any questions whatsoever, it is my job to help you out, and I like my job. So please never hesitate to reach out. Sometimes it takes me a second to get back. Sometimes my phone doesn't give me the notification for a message, but I'm at my computer a lot. So just shoot me a message, and I'll try and get back to you immediately. All right. Thanks for tuning in, guys. I appreciate it. Have a nice night.